The BlackBerry series of devices have become amazingly popular to a certain population, because they were the first technology to really offer an integrated device and infrastructure of communication. And because, at least I've heard, I've never used them, they're very easy to use. They're supposed to be very cool devices, and they're used in various fields in big companies, and they're very popular in governments all over the world. He just complained that I'm doing his talk. But the thing is that not much is known of the technology involved, because it's all proprietary. And tonight we're going to hear some of that, and FX and FTR of PhenoElite are going to shed some light into what has until now been unknown to most of the population. Give it up for FX and FTR.
Hello, and thanks for staying here and not driving home like everyone else. It's the shittiest spot I ever had, but I appreciate that you took the time and actually want to listen to this. So we're talking about blackberries. I wanted to add a little bit stuff in front of it. This is actually not easy. Getting into an entire infrastructure thing that nobody actually knows anything about it is fairly hard, and you can do it alone, but it works a lot better if people help you. And we had a lot of support from very few but very important people while breaking it, and then while dealing with the results of breaking it. So this talk is actually dedicated to those people, and various political reasons prevent me from naming them. So the purpose is, not to be gloomy, but to actually have fun with the devices and with everything else concerning blackberries. So we want to give a starting point. Basically, this is why it is called to arms. We basically want to give an overview of what's there, what's been tried, where did we fail, and we failed a lot. And basically, to give you an idea, and if you're either a hardware hacker or a Windows hacker or protocol reverse engineer or whatever you do, to identify where your field applies and if that looks like fun to you or not. So it's up to you where you take it from here. Oops. So this is what we're talking about. Basically, that's RIM's version. That's what you can download off the websites. At one side, you have a lot of features that the guy who introduced us just talked about. And on the other side, you have what management usually calls crackberries, because they make addictive. Sitting here and talking over a range of wireless networks, then over the internet, through this admittedly very thin corporate firewall, and then into a corporate network and talking to important things like application servers, web application servers, and whatnot. So this was the big picture, and now we basically spend the next hour showing you smaller pictures. And FTR is going to start with the network protocol side.
Okay, the network protocols overall. With BlackBerry found many different protocol layers and protocols implemented. We just had a glimpse on a few of those. We actually will go for the network architecture. We'll have a look into SRP, whatever that means, and the other protocols as named right here. Let's get into the network architecture, which is a more simpler picture than the original RIM picture. Every company gets its own BES that talks to the RIM internal server, which is then relaying the packages out to the devices. The link we focused most on is the communication layer between the BES, between the BES and the RIM external server, because that was the communication layer which was hyped most. in Presscom. And we just want to get into it and we want to see what messages look like and what the content is and who's going to read these messages or not. Okay, the communication layer there between the BES and the RIM internal server actually stays on IPv4. And in IPv4, we get a payload, which is basically SRP, the protocol they use to name server relay protocol. Depending on where you Google for, you find a different explanation of what the name is. The protocol itself is fairly simple. It got a small header, and it got different chunks of where the data are stored in. The chunks themselves looks more or less like this. You have two different types of data which can be.
Please use this laser pointer.
Really cool.
It's much brighter.
Much brighter. It's a blowtorch. I like those. Okay. Back to the topic. The data chunks themselves have two different kinds of. Either they're integer chunks, which are identified by 049 and 49 hex, which translates to a capital I in ASCII, and strings are transmitted as with the tag field 53 in hex, and then after that we get the length and the content. And it took us a while. We just read the hex terms, and later we figured out that 53 is string and 49 is integer, and it just the basic layout of the SRP protocol. In the header, we got these function names, and we got tons of different functions implemented there. Most interesting might be config. The one we had to play with most is data, because that's the one used for transferring the messages later on. So there's a lot of playground left for our fellows of that talk, you know. Basically, we have been able to implement a fake server and a fake client in Perl to communicate either to the RIM server on the RIM side, or to implement the RIM server in order to fake that server to the local BES. Therefore, you need that kind of session setup. Kind of interesting is that the random values down here are just needed once, and so you can just sniff it and take them again and again and again. You just have to take care of the fact that the random seed and the random value have to match. And everything else is as it's laid out here. Inside the SRP, the message itself is transmitted in a protocol layer that's called GME. We found that in the binary, the acronym. We assume it might be generic message encapsulation, but we are not sure about that. And it's used actually for, as I said, to transfer the message from the enterprise server down to the RIM internal side and then onto the device. It's like a simple routing information in the header, which is source, destination, message ID, stuff like that. The general layout of the GME is like this. You have source. It's again a TLV, tag length value protocol. Important is that the source is 10, destination is 20, and application identifier is 50. And you see there's a gap of 30 and 40, and there might be other fields which we haven't seen yet inside the protocol. Important is what I found kind of interesting is that the header is terminated by a 0 byte, which is not like a 0 bit. I don't know what 0 byte, which is against the rule of a typical tag length value protocol. So we couldn't figure out why they interchange so different protocol styles. On the one hand, they use tag length value protocols in different kinds, and then they use fixed size fields and 0 byte as terminator for these fields. Inside the GME, inside the GME payload, we have the application layer. There are different types of application layers. We have CMIME, CICAL, then IT admin, and lots more different stuff. The one we have focused most on is CMIME because that's the one messages are used. That's the one used for transferring messages. What's very important in here is the fact that those PIN messages are transmitted in clear text, even if claimed otherwise everything is encrypted. If you send a message out from the BES to the device with the PIN as destination, it goes over the air in clear text and everyone can read it. It's not really documented on RIM side, but it's documented in the wild. If you know it's there, you can find it.
It actually is documented on a RIM site. If you know exactly what to Google for, you find the document. Interesting enough, there very little documentation and actually very little communication in the developer forums. But this is actually a point that people writing code for BlackBerry are pointing out very regularly in web forums. They will basically repeat and repeat and repeatedly say, if you send PIN messages with the API, it's going to be clear text. Yeah, but to actually find it on RIM's website, you have to know the exact term or the exact phrase to Google for to actually find a document.
Okay, the basic CMIME format is as follows. We have at the beginning the encryption type for the legal encrypted messages. Then you got the session key, we got the key ID, which is then terminated by a 0 byte, which is again not tag length value against all other protocols they use. Then the session key, then a terminator, then the message identifier, and then the encrypted message. The application layer is from here down here, and as I already said, the encryption could be either AES or triple DES. We found those documented all over. Then the key ID itself is sent over the air in clear text again. Session key is encrypted with the device key, and that session key is used later on to encrypt the whole message. 2 words about the crypto. First of all, we aren't any crypto people. We don't know shit about crypto. So we just can say the library used to implement the crypto is FIPS certified, so should be okay. The assembly itself looks also quite okay, so we haven't seen anything there. But Rüdiger Weiss might have a look at the crypto library later on, and maybe he can figure out if there's any special in which is not usual. Putting all these things together, that's a message as it is transmitted over the layer.
Ist der Ron hier im Saal? Er ist nicht in Saal 1.
Bastard. Okay, putting all these things together, the whole message packet looks like this as described here. Starting with the SAP layer, version, that's the data field. Then we have the length of the whole packet, the SAP message number. Then we come into the GME. We have again version number, detect the length. Then we have the documentation of the source and the destination. Then we have down here the key number, and then we get the encrypted session key, and after all the final message, and then some SRP trailer. Since those CMA and since those source and destination are clear text, you can perform traffic analysis on the traffic as with any mail transport layer in the world. So if you are able to intercept incoming and outgoing traffic into a company, you might be able to spot which email address belongs to which device. Since you just send in an email to John Doe, see what SRP message goes out to which device ID, and then you can figure out that this device ID should be ready.